Okay, I think we're ready to go now. Thanks for joining today's webinar, Low Carbon Materials in the Residential Sector. My name's Ken Davey. I'm an industry advisor for the Build Offsite. I'm going to start off with a few housekeeping points. Today's webinar is being recorded, and the recording and the slides will be made available to attendees. So if you have to take a call or if you miss anything, it will be available later. Please raise your hand if you have any issues, or put a message in the chat box. If you have any problems in CIRIA, one of the CIRIA team will actually endeavour to help you. If you have any questions while the speakers are presenting, please type them into the Q&A. And if you wish to direct them to a particular person, please add that information as well. The questions will be monitored as they come in. So if there's anything which you feel you like and would like to emphasize, please add a thumbs up. If you have any resources relating to the topic of today's webinar, please share them in the chat box. There will be a feedback and CPD poll at the end. Please share your views on the various social media sites. And if you have any views regarding the actual topic itself, again, please share them with us. Very, very brief overview of Build Offsite. I actually won't go through this in any detail. You can see that we're over 20 years old now. We launched a new 5-year manifesto this year. Around about 60 members. Members' logos on the screen. Sister organisation, obviously, we're looking at it it's CIRIA. CIRIA has been around for more than 60 years. Again, not-for-profit membership organisation, working on the basis of collaboration, good practice, and improving skills in the construction sector. Between 60 and 70 members for CIRIA. Logos on the screen once again. A quick mention and a quick thank you to WSP, who obviously have been supporting the driving net zero carbon community of practice for a number of years, of which this webinar is part of that initiative. A quick catch up on some of the things that have been happening on Build Offsite. We've been heavily involved in PAS 8700, which was launched in April of this year. Myself and Nigel Fraser took part in the steering group with a wide range of people and skills actually involved. There is a massive potential within that PAS 8700. It complements other publications, and one of the strongest recommendations, I think, is the MMC advisor role. And just a couple of little images to remind people that MMC, although it says modern methods of construction, both of these images actually relate to post-war. And when I say post-war, it's World War I, not World War II. One of the technical authors will actually be speaking at Offsite Expo in September about PAS. And at this point, I've said enough, and I'd like to hand over to our chair for the session, Dr. Kat Ibbotson.
Thank you, Ken, and hello, everybody. Welcome to this webinar. So what brings us here here together today? So this webinar series has been developed to collaborate with Build Offsite and CIRIA's Driving Net Zero Community of Practice to discover how the increased adoption of low carbon materials could support greener practices in the construction sector. Now, we've done a fair few webinars so far, which focus on low carbon and construction. But all of this is aimed to help the UK achieve net zero carbon emissions by 2050. Now, the UK plans to deliver 1.5 million homes over the next 5 years as part of its mission to get Britain building again. Now, herein lies the opportunity, but also the risk. in terms of the opportunity to reduce carbon embedded in building homes at scale using low carbon materials. Now, this webinar will explore how specifying cross-laminate timber, recycled steel, and low carbon concrete could pave the way as we move forward. Now, I'd like to introduce our speakers. We have Patrick Osborne from who's the architect and founding director of Architects Perpendicular. We have Gwilym Still, director, Passive House and partner at Max Fordman. We have Steve Chesters, who's the business unit director at Hadley Frame. We have Matthew Belcher, founder and CEO at Hempspan. Rory Bergin, who's partner, Sustainable Futures, HTA Architects. And joining us for our moderator panel is Orlando Gibbons, who will be moderating for us, who's a senior engineer and an embodied carbon specialist at Arup. Now, moving forward, just a reminder, so please type your questions into the speakers into the questions box. We'll pick these up as we have our discussion at the end. Also to remind you that click on the thumbs up if you like other people's questions. That allows them to come to the top and it helps us identify the most popular ones. So let's begin with our first presentation, which is Patrick Osborne, who's the architect and founder director at Architects Perpendicular, who will be presenting meeting government targets using low carbon materials. Over to you, Patrick.
Brilliant. Okay, thank you very much. Let's hopefully this should work. Well, thank you for the invitation as well. Yes, there we go. So what I just want to talk about actually is combining low carbon materials with adding value in terms of community involvement, as well as some of the research projects we did. So we're architects and consultants. We specialize in prefabrication for the digital age, only using sustainable materials to create inspirational places where communities can thrive. So we do this across three lenses: social value, manufactured value, and environmental value. So the UK is widely acknowledged that the housing market is broken, and we're not producing enough homes, and the majority of homes we need to build being of a very poor quality, with layers of profits extracted for the benefit of companies developing the land, rather than staying locked in within the community. So I've got 4 diagrams here I'm just wanting to go through because it really helps contextualize the problem and start to look at how we can create a solution to overcome that problem. So the first one is a giant iceberg we need to overcome. So what we visually see is very much a capitalist world, which has evolved over many centuries, a system based on a worldview and values which don't align with our desire to build homes which are actually for people and planet. So currently the UK and many other countries are only working on solutions to fix the symptoms, trying to build our way out of the crisis through building more homes. So rather like a sticking plaster than actually getting to the root cause of what the issues are. So really, to achieve lasting success, we need to go much deeper and reframe the mental beliefs which support the entire system above to achieve a more holistic, sustainable, and inclusive design approach. So shifting our economy to enable a systemic change. So one big thing is the need to shift the economies, which are very complex. And it really includes how we evaluate, how we educate, but also it starts with challenging how we define progress and its current measure, gross domestic product. So how can we move from a more cost-based system to a value-based system, which is based on a minimal social foundation, which is the part in the middle of the donut, providing agency to the very communities who will live in the new homes, and an ecological ceiling to ensure more good is done than bad. So the third diagram is a graphic developed by an American planning consultant called Bill Reed, which really instigated the whole movement on regenerative design. And regenerative is used probably overly over the last couple of years, but is actually very specific. So when we aim for sustainability from a systemic perspective, we are trying to strengthen the whole system for both people and planet, where we work in harmony to collectively regenerate ourselves and the environment around us. So sustainability is the first and foremost about systemic health in the environment and resilience at different scales, from local to regional to global. So it's moving beyond net carbon zero to be able to get to a regenerative mindset where we're all in unison together. So finally, just the fourth diagram I just want to add is to do with the circular economy. So it's a circular economy systems diagram, which is called a butterfly diagram, which I'm sure you've all seen before. And it illustrates the continuous flow of materials within a system. So there's two main cycles, the manufactured cycle to the right of your screen and the biological cycle to the left. Both are really important and will be referred to in the following slides. So the manufactured cycle products and materials are kept in circulation through processing like reuse or repair and manufacturing. So it's the way in which we build homes. Whereas obviously the biological one is what we build with. So both are equally important. So I just want to talk about two projects, research projects that we've been involved with. So the first one is a research competition called the Climate Smart Cities Challenge, which happened in a couple of years ago now, of which Bristol was one of 4 cities which put themselves forward. And it's a UN Habitat-backed competition. So we entered the competition through the Positive Collective, which is a collective we've set up, and we became finalists for that. And what we worked with others to try and combat a really big challenge Bristol has is to develop 24,000 new affordable homes by 2050. So Bristol, as with many cities in the UK, has some very stark issues. I'm based in Cambridge, and it's very similar here too, whereby there's a huge number of people waiting, needing homes, but are unlocked. They're out of the system. They're not able to have those homes in the cities where they live. But also, there's a real big difference between in table 2 of the below between the satisfaction in this case with where they're currently living at the moment compared to the average in Bristol. And this is very similar to actually how they deal with sustainability. So what was really interesting in Bristol is the fact that the most deprived communities within the city are the ones least likely to actually be able to contribute in a positive way to the environment or want to change for obvious reasons, because they're very much focused with actually day-to-day living. They need to get the basics right. So this research project was, well, how can we bring these people, these communities, and actually provide them agency, not just to create affordable homes, but also to bring them on board and to help them to allow them to contribute to a more sustainable future, which is another world which we feel is possible. So we created a platform which was called the Civic Exchange. So we worked with various organizations, Igloo Regeneration, which was focusing on finance, Bristol Community Land Trust, We Can Make, and ourselves at the Positive Collective. And what we came up with was a 4-pronged approach for the Civic Exchange, which is one is to have stewarded land. So focusing on and allocating mainly smaller urban infill sites held by the city or by the church or the NHS on a long 125-year lease to encourage long-view stewardship and social value returns. Community value, so looking at insetting rather than offsetting. So making sure that the value stays within the community and the community living there can actually have agency and be part of the financial contributions of the profit. So this goes to the 4th one, which is a long view finance. So bringing a blended green finance model in, so having pension funds, other providers, but also those people living there can buy into the fund rather than buying their individual house. And then lastly, a decarbonised supply chain. So for example, we focus on a small area of Bristol, and what the Civic Exchange allows is to map all of the houses which are both needing to be retrofitted and providing support through the council to enable that to happen, but also all of the houses which could be better fitted. And that's where residents might be bursting at the seams and they need to have a bigger house, and where the next door neighbour might be rattling around in their house and they might need a smaller house. So locally trying to swap people around on a very localised level to be able to have a better fit. So this was a demonstrator project, and we felt that the multiplier was quite significant, because if you're both retrofitting to be more sustainable, but also better fitting, that deals with the vast majority of the housing needs in its own right. And then identifying all of the local pockets of land to be able to build sustainable homes in. So this was all about working with the local community. And We Can Make has been doing this at the moment, and they've set up a workshop called the Norwest Media Centre, and I've got a video which I'll start to play just a short amount from, just to explain how it works.
Buying a house is more unaffordable than ever, and council house waiting lists are the longest they've ever been. Is there another way? Yes! In Knoll West Bristol, we've been creating a new community-led way to unlock microsites for people in housing need. In low-density neighbourhoods like ours, there are often spaces hidden in between buildings and in large back gardens where new homes could be added. We call this gentle densification urban acupuncture. We think it's an approach that other communities could adapt and adopt for their own context. So, how does it work? 1. Start with people. A family might be experiencing overcrowding. An elder might want to downsize but stay in their community. It's an opt-in process. It gives local people a choice to use land that is already in their hands to improve their own housing situation and make a difference to their local community. 2. Ensure the community sets the rules. A design code empowers the community to help set the rules for what gets built, ensuring new homes are high quality and add character to the neighbourhood. The result? It's simpler for people to navigate what can be a complicated design and development process. And when it comes to getting planning permission, the answer is more likely to be a yes. 3. Build for community well-being. When a family opts in, we work with the local council to transfer the microsite to our Community Land Trust. Transfer is conditional on the microsite and home staying in community ownership and fixing the rent at living rent, no more than 1/3 of local household average income. Income is reinvested in making more community-led homes and infrastructure, creating more long-term community benefits. 4. Make the homes locally. It can be tricky to build on microsites because space and access are often tight. To get around this, we use a modular construction system made up of small wooden blocks that fit together a bit like Lego. Using wood means the homes are low carbon and better for the planet. The parts are digitally designed, cut, and assembled in our community workshop. Making the homes locally creates jobs and grows new skills, helping to build community wealth. It also means the community has the know-how to maintain, repair and adapt the homes, helping to meet changing needs over time. Unlocking microsites in this way creates a new way for people and communities to make the homes they need, and in the process unlocks a new way to help make a thriving neighbourhood. Together, we can make good homes, local jobs, space for nature, social infrastructure, community wealth, and a thriving neighbourhood. Find out more, visit our website, wecanmake.org.
Brilliant. I would highly recommend going to We Can Make and the work Melissa Mean has been doing. And they've also been looking now at higher rise buildings, so to 4 stories, and finding systems to enable the local community to build those in their own right. So this is very much a whistle-stop tour, and this is about how communities can be involved in building sustainable homes around them. But now, what materials are best to use? So just the last 4 or 5 minutes is just talking about another research project that we became finalists for, and this is the Home of 2030. So we collaborated with others to design a panelized, so a panel and chunk home using very low grade, so C16 plus cross-laminated timber, homegrown. So we were working with, at the time, Edinburgh, Napier University, Ecotech Systems up in Hamilton to find a way to use low grade cross-laminated timber to build homes. And this was our solution to that. So this was a typical example of a 2-up, 2-down home. And the importance here was to use the right materials for the right elements of the home. So where the existing materials are readily available and are low carbon, then we're not reinventing the wheel, we're using what's already on the market. So what our approach was identifying, firstly, in terms of material, there's a really big issue in the fact that we don't have enough timber in the UK. We're actually the second largest importer after China. But there's real opportunity to be able to grow more. And I know across all governments, there's real need to bring that up from 13%, where we currently are, to more of a European average, using on low grade agricultural land. This is all ideal. It takes time to grow timber. But the other part of it is making the most out of what we've got. So we did a research project where we identified, through using a fully grown Cypra spruce, we can create a typical 2-up, 2-down home from a single tree, which we called a tree for a house. So it was working with others, a few companies down there on the lower right, to identify which parts of the tree are best used for which elements of the home. Obviously, the main trunk for the CLT, the brash for some of the wood fibre insulation, and some of the external cladding as well. So we identified we can produce a home, and I think it's trying to get over the perception that it's okay to use a fully grown tree once it's been able to sequester as much carbon during its lifetime as possible. And also identifying the different elements of the home and the longevity of those elements to enable that during the design process, right from the beginning, we understand how we can disassemble, we can remove elements which have reached the end of their current life, to be able to then replace with updated elements, and then obviously what to do with those elements after their use to enhance them rather than to automatically recycle them. So this is very much a digital process that we did, and it was based on a distributed manufacturing process where we're identifying the existing supply chain across the UK, bringing that knowledge in to create a flying or a field factory where the components can be assembled locally on site and then delivered to their final place. And through our research, we found if you include sequestered carbon, which is a really important factor, that actually our homes are carbon positive, and we've got some statistics behind that as well. So just coming to the last couple of slides, in terms of added value, there's a really huge opportunity here through using, thinking about the way in which we build a manufactured process and what we build with using sustainable materials, in particular focus on biogenic materials, in terms of procuring value, adding additional value. So these are the 5 capitals of sustainability. So we always match what the work we do against these 5 metrics ourselves to make sure that we're really identifying what are the knock-on effects, what are the savings on the NHS, for example, or what are the savings on the residents in terms of saved energy bills. So it's really important to start thinking about how we can integrate these added values as we move forward. And now we're taking this on to actual work as well. So we've been working with mainly SME developers as well as local authorities to really identify how they can actually deliver. So this is a pilot site of 14 homes. We're working with an SME developer in West Midlands. So we've got these homes to be passive house classic homes. They're micro volumetric, interestingly, and they're achieving zero bills as well. So they're a really good example where we're kind of combining the research into actually getting work done. And obviously we feel they look great too. And we've been working with various different consultants across those. And that's where I would like to end. No, thank you very much for letting me speak.
Thank you, Patrick. I think that's a very interesting and informative presentation. So thank you for that. I'm sure the viewers will get a lot from it. So let's begin our next presentation by Gwilym Still, Director at Passive House and a partner at Max Fordman, who will be presenting a case study on standardizing low carbon materials and sustainable design. Over to you, Gwilym.
Cool. Thanks, Kat. Hi, everybody. I'm Gwilym from Max Fordham. I'm the Passive House Director there. I'm going to talk about our experience in the residential sector. I'm mostly going to talk about our CLT experience. Just for background, these are the range of different things we do. So whilst we do lots of MEP, etc., and have done that on some of these projects, I'm mostly talking from the experience we've had of doing the kind of passive house and embodied carbon work on them. And this is principally going to be coming from 4 different completed or on-site projects we've got. So clockwise from the top left, the first building you can see is Croft Gardens. So the 2 buildings on the left and the right are 1 and 2 bed apartments in a pair of blocks, which are curved, and we'll come on to that later. Top right is Bluebird. So this is it's a terrace of houses for a charity supporting the homeless in Southend-on-Sea. This one is timber frame. Again, both of these are all electric and passive house schemes. Bottom right is Alstone Croft. So this has got several terraces of kind of multi-occupancy housing for students. It's a CLT building, all electric again, and passive house. And then bottom left is Hinsley Lane. So this is several hundred bedrooms in terraces of townhouses, typically with around 7 beds per townhouse. Again, it's CLT, it's all electric, and it's a passive house scheme local to us. So there's been a reasonable amount of kind of nuts and bolts side of stuff in this. These are the things that we want a wall to provide for us normally. So if we're going from the top in the labelling, we're on to final finish that people are happy with inside the building. We normally want some form of services void to conceal the services, a primary structure, and then a thermal sandwich. So an airtight line that's continuous and on the warm side of the insulation itself being nice and continuous and working really well, and then a wind tight line on the outside to prevent wind washing compromising performance, and a final weather skin on the outside face of that as well. So when we've used CLT on projects, it's quite interesting at that point, I guess, because on this, that conceptual diagram, it's then doing normally 2 or 3 of those jobs. So it's getting you quite a lot of what you want from the build up, but it's not getting everything. We've generally used the CLT as the airtight line on the project, and we'll chat about that in a minute. It's acting obviously as the primary structure, and it's also working as part of the thermal build-up as well. It's got a conductivity roughly 4 times worse than the mineral wool that normally sits outside it, but nowhere near as bad as concrete or metal frame or something like that would be. So typically for each 100 mil or so of the CLT, you're getting the same amount of insulation performance as you would with 25 mil of the mineral wool on the outside. This does have an interesting interplay, I guess, with the MMC side of stuff, in that there's a chunk of prefab that happens with this, and the CLT comes to site with a lot of the builder's work formed in it and goes up quickly. But there is still those final layers to be formed, which are then happening in general on site. So yeah, air tightness is a really important topic for buildings, both for helping to reduce operational energy use, but also helping with occupant comfort, avoiding cold drafts, and helping with fabric protection for longevity by avoiding the risk of warm air leaking out, condensing within the build-up. Our general experience with that has been that you can view getting really good levels of air tightness as something like a chain. No individual element of it is very, very complex, but all of those links need to be strong and well forged, otherwise the chain fails. And that goes from like, right at the start of the project of setting a really good air tightness target, picking the overall strategy, working that strategy through within the design, then going through into the the final detailing pre-construction, and having a really strong quality control process through construction so that what's down on paper works in practice, and that it gets tested at a point where it's easy to check the work's been done well and to make any remedial work as well without it being really painful, which CLT has generally lent itself to quite well. What you can see in the photo here is a couple of sections from one of our projects. So on the left-hand side, you can see the different lamella. So this was using a 5-ply CLT build-up. And on the right-hand side, you can see part of the reason for having that 5-ply approach. So you can get some cracking within the lamella. And when you do get that, it gives you a risk or a weak point with a risk of air leaking through. So for all of the schemes that we're showing here and talking about and all the ones we've had completed, we've used the CLT as the airtight line. It's a nice robust material. It's being provided anyway as part of the structure, but we've taken the airtight line as being right on the outside face of the CLT, so that the risk of any cracks leading to air leakage all the way through the build-up are minimized. And we've then followed that through so that when you get to some of the detailing that I'll show on the next slide, you're careful to avoid any cracks in that last lamella, kind of undoing all the good work you've done at the junctions. So this is from a project going up on site. It's nice, it's going up really quickly, which is good. We've generally had then, so the strategy has been to use the CLT as the airtight line, and to then have windows and doors sat on it, which are to a really good spec, and the interface is carefully detailed. They've been interesting from our point of view, I guess, because there's some standard practice things in that everybody tapes the junctions between the CLT as a matter of practice anyway to protect against moisture. So all we've needed to do to achieve really good levels of air tightness is to be careful with the detailing and change the spec of that tape and not introduce lots of additional products. On these schemes as well, we've generally used the CLT as the thing that supports the windows, not because it was much better thermally than alternatives, but because then it helped to limit the number of trades and keep things simple and fairly speedy on site. The next image shows a couple of the slightly more fiddly details that you can end up with. So on the left-hand side, you can see where we've got an end grain of one panel butting up against the next panel at the corner of the building. This is showing the initial taping, and you can see the tape is sort of just lapping over the joint between the two, but not going particularly far beyond on either side. From our point of view, that creates an air tightness risk then, because some of those cracks between the lamella could effectively bypass all of the tape and come right to the edge. So where those details do exist, we've ended up with the tape lapping right the way over the end grain. And normally that end grain, at least for intermediate floors, has a sealant applied to it, and that's still been kept. And then we've had a compatibility check done to make sure that the tapes that are doing the air tightness side of things can work really well. The image on the right-hand side is from a panel being moved into place. So you can see both the nice side, that it's some pretty big chunks of structure moving around fairly quickly. Then there's the follow on that actually the thing that's holding it up and letting it being moved around is some lifting holes or lifting eyes in it. And so that gives an extra detail to be dealt with. So this needed to be run through and made to work from both an air tightness and a fire and acoustics point of view. But to give a couple of figures for this, so these are the this is what building regs would ask you to achieve for air tightness. So a permeability of about 8 now. This is what UK good practice would be with a permeability around 3. From a passive house point of view, we're looking at permeabilities of 0.6 to 1, slightly different metric, but in that range. And for the passive house schemes that we've done, we've now managed to get them to at and below that passive house limits. And more recently, they've been far enough below that limit that actually we've been relying on a better level of performance. So for Hinsley Lane that you can see here, we've worked to a better than passive house level of air tightness and used that to mean we don't need quite as much insulation in the wall build-ups. Sorry. A point just to flag is you can get some interesting bits with geometry on these. So on Croft Gardens, you can see we've got curved buildings, but the primary structure behind is planar. So there's some fun and games to take out the difference between that curved external line and the primary structure behind the scenes within the cavity. And I think the structural engineer had fun with the roof detailing to make that all work. From the noise side of things, I think timber's lovely. Having it exposed is great, but often acoustics trumps that and it gets quite tricky with flanking details and so on. Here's a couple of examples where it has been achieved. So you can see little bits from this corridor of this project. It's at Cranmer Road in Cambridge. And then within some kitchens, there's exposed CLT, but it's then complemented with these acoustic baffles. And I think you can get really nice rooms and experiences with this, but you can also deliver really lovely spaces with, say, exposed timber in the flooring and the furniture instead. We found there's quite a bit of coordination needed for the penetrations and that side of things and getting into detailing. And so that includes from left to right, the lifting eye side of it that we mentioned already, the MEP side of things in terms of builders work and coordination with the MEP design, and often bringing that a little bit further forward in the design process than it normally is. And the right hand side is from the timber frame Bluebird project, where the cupboard you can see houses the MVHR unit on the thermal line, but there were some coordination issues that came up late in design, just to make sure that what was detailed actually worked, because some of what got delivered to site was a little bit different from the design initially. I think similar to what Patrick's talked about, we've looked at it from the embodied carbon point of view. I think there's some interesting bits to be careful of with those. So the upfront carbon of the timber frame projects have generally been better than the CLT. You can see some sort of crossover during construction if you include the sequestration side of things, which often then gets slightly unwound at the end, depending on what the assumptions are for end of use. But I think, and this is an idea that I'd heard from other people, not one of my own, but this idea that you have to be really careful, because any metric that tells you it's better to build like one house with 2 trees rather than 2 houses with 1 tree must be sending us down the wrong routes. And we've seen some people, I think, on other projects try to put a bit more timber in to count the sequestration and sort of offset a bit of extra metal somewhere else, which always seems a bit perverse. And then very briefly on the kind of thermal performance and detailing side of things, we've seen the CLT then help and contribute with a few other things. So this is from the Croft Gardens project. This is where the substructure meets the wall. You can see the CLT here. that's actually ended up meaning we could have a thinner than otherwise concrete slabs. There's a bit of saving in the concrete there, and then have been able to wrap the insulation around that entirely. So we've got really good thermal performance and limited thermal bridging. That isn't always possible. So this is from another project. Smith & Moore work at the structural engineers on it. The CLT is dropping down here. You can see the kind of default solution with a convoluted thermal line and then some redesign. So touching on the CLT, but also other bits to make the detailing simpler and effectively use some concrete piers to do that coupling up, which then ends up meaning it was thermally better, easier to build, cheaper, and we took out some insulation from beneath the slab as well. So we've talked about there, I guess, a couple of different examples of bits where we've tied through CLT to helping with both low embodied carbon and also some knock-on impacts from them. But as Ben Goldacre said, it's a bit more complicated than that. So here's one list of a lot of different primary structure considerations that come up on projects. I don't think there is a single solution that wins on all of these different measures. So like with many design decisions, it's driven by a balancing act of picking what's best for that particular project. But at least it's good to go through that process quite thoroughly and make sure that everything's being considered and there's a deliberate choice. So at that point, I'll say thanks very much. If you do have any questions, please put them in the chat as well. I'm afraid I can't stay right until the Q&A session at the end, but I'm happy to try and answer bits in the background until I have to leave.
Thank you, Gwilym. Moving on to our next presentation this is by Steve Chesters, who's Business Unit Director at Hadley Frame, who'll be presenting on sustainable construction using low embodied carbon steel. Over to you, Steve.
Thanks, Kat. Good morning. I'm Steve Chesters. I'm the Business Unit Director of Hadley Frame, which is the construction arm of the Hadley Group. Thanks for joining. This morning, I'll be talking about the role of low embodied carbon steel, particularly light gauge steel, in helping us deliver more sustainable residential buildings. I'll look to try and keep this practical and focused and looking towards more current trends and policy. Before we start on that, we're going to add a poll in this morning. And if you can look at voting on one of the options, and then I'll revisit that at the end of the presentation. And it'll be interesting to see what you're finding with your current experience. So the poll question is, what are the biggest challenges you face when specifying low carbon materials in residential projects? Lack of verified carbon data, availability from suppliers, cost premiums, conflicting design requirements, planning or regulatory uncertainty, contractor resistance or inexperience, unfamiliarity with standards or EPDs, client budget constraints, short project timescales, or any other. Might be one, might be a few, but I'll certainly be interested in what the consensus of opinion is. Okay, moving on to the presentation. So, as has been mentioned this morning already, and we're all very aware of, we need to build more homes, more residential dwellings, and we need to build them quickly. 1.5 million by 2029. I'm sure we've all got our opinions on how achievable that is and how we're going to do it and what knock-on effects there'll be from that. But every new home we build is going to add carbon into the system. Approximately 20% of the construction industry in the UK sector's emissions come from the materials themselves, rather than the heating or lighting, which is what we're referring to as the embodied carbon. The embodied carbon, unlike operational carbon, is locked in on day one once you add that into the structure. So there's no real opportunity to be changing that later on, like we've got with operational carbon. So the choices that we're making on the materials and how we're using those materials, especially in housing and especially with the volumes that we're looking at, are going to impact enormously on whether it's going to be achievable to meet those net zero targets at the same time as meeting the commitments on the housing that we have. So looking at light gauge steel systems specifically, like the ones we provide through Hadley Frame, they can offer a real option that can be an important contribution to the overall solution for the industry. The first thing is the strength to weight ratio of cold rolled steel is very high, which means they're very strong, but they're very light. So this has an impact on the actual volume of material that's being used and the mass of the structure itself, which is then got a follow-on impact with what you're doing in the ground. So what type of foundations you're using, how much you're using in those foundations, how deep they are. It's also generating less site waste from that as well. The systems are manufactured off-site, so we get faster builds. We're using tighter tolerances, and we're less affected by weather delays as well. Crucially, they're fully recyclable. Every piece of steel in the panels can be recycled or reused endlessly. When you're building homes and you're looking to meet program targets as well as carbon targets, this is ticking both boxes. So a quick example, there was a study by Delgado and Herrera in 2023, and they were comparing light gauge steel framing to a concrete and masonry structure. And they found that the steel solution had 33% less embodied CO2 per square metre, and the walls alone were 50% lower in carbon. What was driving this? Well, mostly it's the mass. There's far less mass involved in the steel structure. There's no cement, and the logistics involved were far lighter than they were in the traditional build. Even compared to hot rolled steel, cold rolled steel avoids a lot of the energy intensive process that's from the creation of the product. Steel's recyclability really is unmatched. It doesn't degrade. Over 90% of steel in UK buildings is either recovered or reused and recycled. There is very little that goes to landfill, and there's some statistics that have shown higher percentages than that. Light gauge steel is really very useful within this recycling area because it's clean, it's very consistent in its structure, and it's a mono material. There's no glue, there's no filler, there's no composites that are complicating the recovery of the product itself. So scrap steel has value, and it's an important part of that circular economy that's already existing and already thriving, and it's one that just needs to be expanded more in order to reduce the carbon that's going into the structures. So recycling is really important, but it's not all about recycling. There's a really good document that was recently written by iStructD and the BCSA. One of our chartered engineers, Stephen Hall, recommended that I review it when we were talking about this subject. And I can't recommend it highly enough. I'm going to point to it again in another slide later on. It's very interesting. There's a lot of good insights into the engineering and where they think we should be going. But one of the things it's strongly emphasizing is design for reuse. And building residential structures or more commercial structures, if we're building them from demountable panels, and using components that are bolted rather than welded, and designing them to be literally taken apart and reused, then it's going to be an enormous benefit to what we're doing in the future. And modular, again, we produce modular structures, and modular supports this as well. You could be producing a modular structure that's designed as maybe a temporary classroom or a temporary health unit, and that can literally be reused in its own form for maybe accommodation for homeless people, or a housing extension, or restripped, or even a site accommodation. We sometimes use structures for it again now. So these are where light gauge steel framing and modular systems really come into their own. Also, the new BS 1090, that standard now includes a deconstruction annex, and it's a clear signal that reuse is now being taken seriously within structural design. So just to touch on green steel, it's a real buzzword in our industry at the moment, in the steel industry. It's quite complicated. It's not as straightforward as one product and one product achieving everything that's desired out there. There's different routes to green steel, and there's different values behind that. We could easily do a full presentation on green steel in itself, but just to try and clarify it a little bit in broader terms, some green steel is green because it's made from scrap material and it's produced in electric arc furnaces, as opposed to the far more common blast furnaces. There's also an option for using hydrogen instead of the coking coal to reduce the iron ore content which is used within the blast furnace manufacturing of steel. And then there's another route to green steel where it's really an offset accounting method, where steel is produced with a carbon content and they might allocate a higher carbon content to half of that batch of steel so that you can allocate a lower carbon content to the other half and reband that as a green option. What actually matters is the emissions per tonne and not the label. It's something that we look very closely at with Hadley across all of our businesses. It's very important to us what steel we're buying and what steel we're using. And as green steel supply increases, and more importantly, as the demand for green steel increases, we'll be looking at more of that and integrating more into our systems. But the first step really is transparency. Transparency and understanding what you're buying and knowing what its footprint actually is. So this is the report on the slide here that I mentioned before, the iStruct-E. And one of the things that it really makes clear is we can't recycle our way to net zero, and that's something that really hits home with me. There's not enough scrap steel in circulation to meet our future demands. And in the bigger picture, we're not just talking about steel here. We're in very similar circumstances with most materials that we're looking at. We can't just keep recycling and thinking that's going to solve the problem, because we're increasing the volumes that we're doing. So recycling with steel is vital, and primary steel production still needs to be looked at, as we just said, with decarbonising that process from hydrogen, CCS, and electric furnaces. But we really need to be smart about this. We can't keep thinking that we'll fix it later. This is a problem that needs to be addressed up front, and not one that needs to be just exclusively looked at retrospectively. So that means we need to look at the design, understanding our design. And this is down to designers and clients alike, really. We both need to, they need to be supporting both sides of this, which is minimizing the steel, minimizing the specification, and really specifying low carbon sources wherever possible. And then as manufacturers and constructors, we need to be looking at keeping those designs as lean as we possibly can. And to be fair to government agencies and departments, policy is catching up fast. The proposed Part Z regulation make whole life carbon assessments mandatory, and we're expecting that there'll be limits to follow this as well. We're seeing procurement shifting. Some contracts that we're bidding for are now looking at scoring the carbon tender in the evaluations. The London plan's already demanding carbon assessments, and we expect that will be following in more cities. Timber's getting a big policy push too with this, and I say this with someone within the steel industry, because there's room for all solutions. Anything that's good for the environment or good for the economy is going to be good for the industry, and that's really what we're supporting. But steel does have its strengths in durability, fire resistance, and in its mid-rise capacity that timber can't achieve. So we need balanced solutions for low carbon steel and the industry in general. So as I said, we need to be smart. We've got a choice to make at this juncture: keep building the old way, or we adapt and look at new ways, smarter ways of building in the future, so that we're not just relying on recycling the content. Light gauge steel gives us a better chance to build better, faster, and to build greener. We can be certain that regulations are going to get tougher, and buyers are going to expect carbon data, and planning teams are going to want to look at life cycle thinking. Us at Hadley Frame, we've got into this mindset. We're looking at the lower carbon options for steel, and we're designing for deconstruction and trying to collaborate with our clients to achieve these goals as much as we possibly can. So thank you. I think we're just going to revisit the results of the poll a week.
Yeah, that's fine.
So interesting, it looks like the planning and regulatory uncertainty is pretty high there, and it's just what we're looking at, some of those changes coming in. So I'd expect that, and limited availability from suppliers. I think that's something that we see as well. I mean, we get asked for green options on green steel, but we've got a limited supply of that as well, and then that knocks onto the cost premiums, which interestingly is only 38%. I thought that would probably be higher, but yeah, some interesting results. So thank you very much.
Lovely. Thanks very much, Steve. So just a reminder, please type your questions into the questions box, and if you see a question that you want answered in our panel session, please do a thumbs up to that. So our next presentation is by Matthew Belcher, founder and CEO at Herein, who will be presenting on building climate positive homes at scale. Over to you, Matthew.
Thanks very much. Good morning, everyone. So Hemspan, we are a relatively new business. We are a construction technology company, and our mission is to develop the bio-based building technologies and circular systems to enable mass adoption of climate positive living. We like to express the challenge that we face in construction and infrastructure as well across the globe, that nearly 40% of global carbon emissions are as a result the impact of humans and the built environment. We also focus on the very worst of house building in the UK, where you know, the sort of basic minimum requirements for building standards can leave us with homes that have whole life cycle embodied carbon emissions at 1 to 1.5 tons for every square meter of new space that's delivered, and we don't think that's good enough. And you know, REBA 2030 target, which lots of people on the that have joined this will understand, is at 0.63, which would be an amazing outcome, but it doesn't go as far as as we think it should. And because we're a construction technology business, it allows us to focus on a core component, which is industrial hemp. And the reason why industrial hemp is our focus is all about biomass yields and carbon sequestration. Structural timber is a key dynamic for what we do. And as we go forward, we are looking to displace timber elements with composite elements that we are developing in parallel through our R&D programs. But essentially, 1 hectare of industrial hemp can absorb 11 tons CO2 each year. And that's just into the stem material above ground. And, with consistent yields up to 8 tons recorded in the UK in just 4 months of growing cycle, which is, truly exceptional. Obviously, there's a huge number of things that can be achieved with hemp once it's been harvested and processed, from insulation, particle boards, composite materials, and lots more. We're really only focused on construction and where the products or the raw material can be optimized into our building system, which I'm going to introduce shortly. Depending on how the crop is farmed, there's a lot of potential to sequester further carbon into the soil, which we absolutely don't count in any of our analysis or carbon equations. But in partnership with farmers that we're connected to, we're looking to establish robust farming systems for large-scale adoption of industrial hemp. So Hempspan has developed a Category 2 MMC system, closed panel. It's a Larsen Truss timber frame system, and the system is called Biohouse. We're very proud of what we've developed. We're also very proud of our trademark. And essentially, when we say climate positive, we're talking about the plots themselves. We are not talking about site-wide infrastructure. That is not something we can currently control. But we're essentially saying that at practical completion, that we're locking up more carbon in the materials than is emitted in the manufacturing and construction phase, and that we're delivering homes with our development partners and design partners that produce as much energy as they need over a calendar year, albeit with the obvious export-import balance through winter and summer. So the Biohouse system is fully developed. We were lucky enough to achieve BOPAS accreditation beginning of last summer. And we're working also with ICW for warranty and their advanced assurance program. All of our carbon data has been verified through 8Versa, who are a carbon consultancy. And whilst the performance of what we've developed could achieve Passive House accreditation, we're more focused on presenting a climate positive program with 8Versa and their natural carbon solutions program. So in order to achieve accreditation, obviously we've done all the structural engineering and design required, physical fire testing. So the Biohouse system has a 2-hour rating, which means we're accredited for residential and public buildings. So we're very proud of our fire test results, and I think it's a first for a bio-based system. So we're very excited about that. We believe we can go higher than 3 stories, depending on the site, but we haven't yet had a structural design to take through BOPAS to get it approved above that at this stage. All of the acoustic analysis, thermal analysis has been done, and as well as the important hydrothermal testing that we needed to go through. What's really important is, and the image on the left is showing you that our system is facade agnostic, which is a phrase I like to use. So where the biohouse system is deployed, we're not asking, and we don't require architects to specify timber cladding or hemp cladding or anything else. And we effectively want the biohouse system to be, a go-to superstructure technology for architects and developers across the UK. So in terms of sort of key benefits and what we do when we do design, and at this stage, in order to prove our technology, we are set up as a design and build contractor, whilst we sort of move into in-house manufacturing next year. When we design, obviously, we look to onboard all existing and best-in-class renewable technologies. The biohouse system in its raw form is effectively carbon negative in construction, providing we can account for biogenic carbon. And as I've already said, delivering homes that will produce more energy than they need across the calendar year. And that's not just regulated energy, that's unregulated energy as well. We've taken, obviously, passive house principles in our work. We're delivering structures that will have a air tightness below 0.6 or below. The aggregate U value of our system between roof cassettes, external walls, and foundations is targeted at 0.1, which is at the sharp end of thermal performance. But what we've developed is not lightweight. Mass is a really positive dynamic for us, and having good thermal mass is an important part of our thermal strategy. Through our analysis, we expect, once we're in vertically integrated production, to have life cycle embodied carbon at 100 kilos per square meter GIA, or 0.1 of a ton, which really would set a great benchmark, and that's across all the way from A1 to C4. Just showing you some of our standard detail examples. These images have not come out very well in the presentation, but you'll kind of get the gist of it. As I've already said, we've got a Larsen truss closed panel design. We've got an inner load-bearing stud that's carrying all the structural vertical loads, and that is strapped to an external stud, which is much smaller, which is carrying wind load and cladding load. It's effectively cantilevered off the internal stud. And by having this Larsen truss design, we're able to maintain an almost continuous insulated core through the panel, through corners and all the details. Roof cassettes are effectively a posi rafter structural design with a full fill of hemp fiber insulation. And we have 2 layers of our hemp particle board called bioboard on the inside face of the roof structure, the roof cassettes, before a final plasterboard finish. Same principle is in the external wall build-up, where we've got a full fill of hemp fibre insulation at just shy of 300 mil. And then there's an OSB racking board either side of the studs, and then again 2 layers of our bioboard product. We provide an internal service void to enable trades to get on and do their bit once the superstructure is installed. The air tightness layer, and it's an intelligent vapor control membrane, sits on the face of our hemp particle board, one to provide air tightness, but to also ensure that no moisture excessive moisture can penetrate into the panel. And of course, on the outside of the racking board, we have a breather membrane as well. We have simplified already some of our sole plate junction and interfaces with foundations. The projects we've been involved with to date, we've used a raft foundation because it gives you that thermal mass within a fully insulated slab, which we like. And you know, we've already managed to sort of design out this toe detail, unless we have a full brick or stone facade where this would be necessary. We are currently on site with one of the UK's most prominent landowners. We will be putting out some news around this in the coming months. And this is effectively the first deployment of the biohouse system and our case study project. And our life cycle embodied carbon stat for this house, based on the full fit out specification, was 142 kilos. And as I'm showing in this chart above, we expect to go below 100 kilos once we're in vertically integrated production. Predicted EPCs on this project are 114%, and yeah, we're really excited about this. We have a conversation with Octopus about their zero bills for this, and obviously quite unusual for them to have a house that's only got solar on one elevation to meet their test. We are just going to put up a poll. Thought it was important to share what we do first. What do you believe is the most important factor in delivering truly sustainable housing at scale? And there are four options there: use of carbon negative materials like hemp, local job creation and community benefit, speed of efficiency through MMC, and I think everyone's favorite, planning policy. So I'll let that rumble on while I finish off. We are involved in land promotion, where we partner with landowners specifically, and we're promoting a very large site in South Essex for 2,000 homes, which is a unique opportunity because the landowner were the biggest grower and processor of industrial hemp in the UK in the 90s and 2000s. So there's a strong bond between their legacy ambitions and our technology business. So we're looking to deliver the first large-scale climate positive community in the UK, and provide innovative future-proof jobs for local residents. And we're working with a award-winning architect to deliver a level of placemaking that would be worthy of the way that we're approaching the project in terms of design. The key features of the project is we think we're going to provide 1,000 new jobs, half of that through our vertically integrated production facility, and half of that through new local trades established, as well as within the new employment hubs at the core of the project, and lots of other benefits as well. We've largely got farmland that we'll be developing on, which has a very low biodiversity level, creating lots of new habitats for wildlife. There'll be a tourism element, yeah, so providing a real boost to the local economy, education, creating a vibrant neighbourhood, and you know, a 20-minute neighbourhood is the core strategy. So we're working with Adam Architecture.
Hi, Mark. We're running over 2 or 3 minutes now. If you could try and wrap up, thanks.
No problem. You'll see some things hopefully coming out in the industry around this partnership, and also looking at how to provide the local community with ways to minimize the impact of the development. And we have detailed designs and business plans for a vertically integrated production facility. That's raw timber and hemp coming in all the way through processing, manufacture into biohouse panels out the other end. So thanks for listening, and I'll be around at the end to take questions.
Thank you, Matthew. And moving on to our next speaker, we have Rory Bergen, who's partner Sustainable Futures HTA Architects, who will be presenting on designing the world's first volumetric building over 40 stories using low carbon materials. Over to you, Rory.
Oops. Thank you, Kat. So my role in HTA is to lead on sustainable design, and also to make sure that as a practice that we are keeping up with trends in the industry, and in sort of recent years, I would say that a lot of these issues that others have mentioned, so the use of bio-based materials, for example, and so it has been challenging, I would say, in the last few years, because what we've seen is a general, and this is coming out of the Building Safety Act and the arrival of the definition of higher risk buildings and so on. So we've seen a lot of changes in the sector about what the attitude to risk is. So I suppose as a background to all of this, innovation, I think, has become difficult in the sector, but it's interesting to see, how other people are dealing with some of those issues in the sort of previous presentations. So HDA, we're our architectural practice primarily, but we also encompass landscape architecture, sustainability, consultancy, and interiors, technical design. We like to build buildings, so we don't sort of just get involved in the concept stages. We like to build buildings and see them through. We're interested in the places that buildings are in. So we don't just focus, if you like, on the sort of the design, but on what will the final place be like when people come and live with it. And we spend quite a lot of effort on visiting places after we've built them and interviewing residents and so on to see how they're working. And we try and have a little bit of fun while we're doing that too, which is important. And we work a lot with residents. So I would say almost all of our projects involve consultation, community engagement, community events, and so on. And that's just something that we've gotten sort of, we pioneered as a practice many years ago and have kept an involvement in since. And it's a very rewarding part of our activity. And of course, trying to be as sustainable as we possibly can in the process, and keeping up with current legislation and the availability of materials and the availability of different systems and so on. And so we have a team of people who are perhaps specialists in their own way, but then we bring them together to try and offer a comprehensive advice across all the usual, I suppose, what you call the usual sustainability issues that designers have to deal with in the sort of modern construction sector and in the residential sector and in London. So it's not just about some building regulations as the sort of bottom of the tier, and then it's the GLA, and then it's client requirements and sometimes funding requirements. A really interesting thing we've seen over the last decade or so has been the increase in demands for more sustainable approaches from the funders, sometimes going beyond policy. So that's an interesting development. And one of the areas that this has sort of moved us into is the sort of innovative construction, in particular tall modular buildings. We have a large portfolio now of completed projects up to 48 stories of steel framed, self-structured, self-supporting modular structures. And It's interesting at the moment. We're having conversations and actively helping clients in cities internationally at the moment, much more than in the past. Partly because, well, in fact, mainly because of this experience, because what we're seeing around the world is cities, in the same way that London is, cities generally are finding it difficult to keep up with demand. So successful cities around the world have an issue where they want to build more, say, usually more housing. They're not able to, for one reason or another. They're not able to build quickly enough. And the result is the market is constrained, homes get more expensive, rental level goes up, young people find it more difficult to rent or live there, and that has a knock-on effect on the local economy and on the success of those places. So there was a recent article, I think in the Financial Times, on how London's productivity, which used to be ahead of the rest of the UK, is now at or below the level of the rest of the UK. And I think it's partly because of the exodus of people from London because of unaffordable housing. So, it's a big topic, and we could run a full day seminar on the topic on itself. But it's been interesting to us in the last few years how much interest this idea is getting from other cities around the world. And we've built a lot of buildings and are continuing to build a lot of buildings. And generally speaking, they've been built at about 50% of the time of a typical construction project. So if you're building a student building, or if you're building a rental apartment building, which quite a few of them are, then the sooner you get the buildings completed and ready for occupation, the sooner they can start to pay back loans, pay back finance, etc. So there's a lot of benefits to clients in going down this approach. But I think I would say that the interest worldwide is more about productivity, more about getting things done, and maybe less about necessarily the speed of delivery or the finances. That many cities around the world are finding it difficult just to get enough housing built in time. We take care not to make buildings look as though they were prefabricated. While that's an interesting aesthetic in itself, it's not something that we feel you can use again and again and again. So our buildings tend to be made from modules which are built in a factory, usually in the UK, and then brought to site. The building is erected, and then a cladding system is applied to it. And that enables us to reflect perhaps local materials, reflect the need to create a design which is attractive. Perhaps it's a landmark in its own particular location. So it enables us to be responsive as designers, and also to create interesting buildings, I guess. And although these come from factories, they are by no means restricted in terms of the shape, size, and so on. So this diagram is a diagram of many of the modules that we've used on a number of different projects. And this happens because sites are not squares. So you frequently have to build a building to fit the site that you've got. So, and particularly in dense urban environments. So it's important that the sort of construction methodology and the approach to designing and manufacturing is flexible enough to be able to make that work. And that you have the benefit of perhaps a tall building, 20, 30, 40 stories, and you have the repetition vertically, rather than expecting everything to be sort of made the same way. So, talking about embodied carbon and following on perhaps from some of the things that Steve was saying, we find that because of the lower mass of the steel in construction, so these buildings have a concrete core and concrete floors generally, the concrete floors being built into the modules. But generally we are at or below the the bands required to meet the London plan. So the London plan is the 800 kilograms of CO2 per square meter, and the REBA 2030 band is 625. So we're kind of hovering around there, and with some smaller buildings, we've gone below it. It's going to be interesting to us to see over the coming years, what the advent of perhaps green steel or the decarbonization of the steel industry, as well as the decarbonization of the concrete industry, what impact that's going to make. And it's interesting. We sit as both architects and sustainability consultants on our projects. So we as sustainability consultants would push the architects to do X, and the architects and us will push the contractor to do X. But sometimes there are program reasons why that can't happen. So for example, the use of GGBS generally slows down the curing time for concrete, which has an effect on the program. The availability of GGBS is dropping because of the decarbonization of steel. The closure of Port Talbot, it means that there's less of it available in the UK. We probably don't want to be importing GGBS in order to make buildings more sustainable. That doesn't really seem like the right approach. So we're in a constantly changing environment, and I'd say in our practice, these issues never stand still, and it's very difficult to get to a point where you've got a reliable solution that you can use again and again and again. But what we like about the volumetric modular approach is that the construction process is so smooth, so quiet, much less disruptive. People have a much better life in the factories than they do roaming around the M25 at 6 a.m. in the morning in a white van. And people tend, manufacturers, they tend to move close to the factory and then cycle to work. So there's sort of huge downstream benefits which are often invisible in the process. So while the embodied carbon numbers are interesting and important, they're only one factor in the sort of total process of designing and constructing these buildings. And as a practice, we collect the data on them, and it's been interesting, to look at charts like this, which plot our buildings. So the energy use is the orange bars, and the embodied carbon use is the orange dots. And you can see that while there's a sort of a downward trend on the energy side, the embodied carbon side is really quite chaotic. And it varies a lot between building typology and the construction system that's related to it. And this is just the embodied carbon numbers, and it's very hard to see a trend. What we are seeing is that the upfront carbon, the blue dots, is hitting or around the GLA targets, but the overall performance of the buildings is still quite chaotic. And this may be because we don't have enough data yet. This data is collected on our own projects, the projects that we as a practice are involved in from a sustainability point of view. So it would be, people like Max Fordham and others also do embodied carbon studies of our buildings. So it'd be interesting perhaps for us to collect the data from those and bring them all together. It'd be nice if the GLA produced something on this themselves, given that they have quite a lot of data from all of their projects. And then, as well as all of this sort of...
Just 1 minute, Rory, just 1 minute left.
Yeah, so as well as all of this, the places that we build, we do a lot of large parks, part of the landscape team, and it's sort of been interesting for us to look at that. And this project we're doing with Regent's Park, where we've been actively trying to reduce the embodied carbon in the construction and design of public open space and public realm. And we found that when we look at the planting, by reusing crushed material on site, So by creating soil types which use finely crushed material on site, we can get the embodied carbon down to a very low figure. And when you look at the green bar at the bottom right is the amount of carbon sequestered in the plants on the landscape. That takes care of about 40% of the remaining carbon. So it's a really interesting area for us as a practice because we do quite a lot of this work. And it's something that we will do more work on as time goes by. And then as a practice, how do we account for the carbon in the buildings that we are involved in? Scope 3 emissions is a complicated task. And perhaps by bringing together the emissions from our planting work together with the emissions from our construction work, we can get a more comprehensive picture. But it's a lot of data, and it's a surprisingly large amount of work to collect all of this. So perhaps that's something for us to discuss in the Q&A.
Pause you there, please. Rory.
Yeah, that's fine.
Okay, thank you very much, Rory. We'll now move on to our panel session, and I'd like to introduce our moderator, Orlando. So over to you.
Hi everyone. Thank you so much to the presenters for those fantastic presentations. Firstly, yeah, really, really interesting and great variety of stuff there. So yeah, can I invite all speakers to turn on your microphones and webcams again so we can all see you. We've had a couple of questions so far in the Q&A, but please, if you've been kind of just storing up your questions for the Q&A session, do drop them in the chat now, because we'd love to get your input from the audience. So we'll start the first question in the Q&A box. Do you see a shift in client demand towards lighter, digitally enabled framing systems? And I think probably ask that one of Steve. If you want to go first.
Yeah, sure. That's a really interesting question, especially when we look at the lighter part of it. So I would say yes, but they're not always conscious of it, especially clients. A lot of clients just want the projects built. A lot of them aren't as motivated by the other elements of it, such as the carbon level. It depends which sector we're talking about. And there's a lot that are just motivated by the finance side of it. And my background is the money side of construction. And really that is what's driving most of construction at the moment. It is the cost of construction. And this can be a bit of a nice to have. But having said that, lighter means cheaper. You've got less structure, it's going to be cheaper. So we are driving lighter designs and more efficient designs, which is giving us that effect of having less mass and less embodied carbon and a more efficient building. But whether that was their main goal for asking for it, I think we're still in the area of education, and it would be a nice to have, but really cheap is still what they're looking for at the moment, especially with the interest rates.
Yeah, that makes sense. Thanks, Steve. Rory, I was wondering if you haven't had anything to add to that question, because it's fantastic that you've gathered so much data from all of your projects. And I know that you said the embodied carbon results are quite chaotic, but wondering whether you've managed to kind of dig deeper into what the characteristics of those lower carbon buildings are.
Well, I think the lower ones tend to be the prefabricated ones, because of the reasons we've already talked about. Lower mass, lower amounts of concrete in particular. But I would say that our experience in the last 4 or 5 years has been that unless you've got a very comprehensively tested system, it's very difficult for us as a practice to continue. So the volumetric modular systems we've been using have got excellent fire testing and performance characteristics, but we've found on the framing side, it's very difficult to find companies and with the possible exception of Steve and his team, companies with comprehensive fire testing, certification, and documentation. And if they don't have it, as a practice, we can't use it. So yeah, we're in a much more risk-averse world than we were pre-Building Safety Act. The legal implications of things going wrong are just impossible for an architectural practice these days. So, and that's driving us and the industry to away from innovation. So we need as a sector to do something more comprehensive about that problem.
Yeah, well, I mean, Matthew, your system seems to kind of tick a lot of boxes in terms of reducing carbon and addressing all of the. And you've got fire testing rating, which is brilliant, for those bio-based materials. Do you kind of see any challenges in getting clients and to adopt your system? Kind of what are the biggest challenges you're coming up against in conversations about kind of getting your system more widely applied?
Yeah, it's interesting because obviously we're not lightweight and designed not to be, and we don't overuse timber. But we are hemp heavy and deliberately so because thermal mass is an important dynamic that we're embracing. In terms of client adoption, I think we've only really just come to market, but we are attracting interest from a number of regional house builders. With our large project, we're working with one in particular that I won't name, who are already doing higher standard of design, airtight, similar sort of M&E spec. And this is what the jump with us is to really address the fabric and the carbon challenge in terms of fabric. That's just a good fit. But one of the barriers, dare I say it, is that NHBC is the kind of dominant warranty for house building, and BOPAS is great. Other warranty providers are great, but there is a wall that gets put up there that we're going to have to navigate through additional accreditations. It's not a problem, but we don't want to go through that until we've iterated and we've displaced some of the timber elements with the new composites that we're developing. So I guess that's a barrier.
Yeah, no, it's really interesting to hear what those barriers are to these kind of new lower carbon solutions. And Matthew, another one for you on kind of the cost of the system. I know kind of Steve mentioned that was kind of one of the main client drivers as it is on every project, understandably. How does the cost of your system, I know you've only just kind of come to market, but how does that compare to the typical kind of concrete block system that you were comparing it to in terms of embodied carbon?
Yeah, so basically at the moment we're outsourcing, but from next year, once we're in production, we should be able to supply the biohouse into projects and allow house builders to get to 220 to 230 pound a foot based on the specification I've shown you with the case study house, which is a pretty good spec, ultra high spec M&E. So and we think that's close to the sweet spot for regional house builders. In fact, we know that. Our vertically integrated plans will push us below £200 a foot for the same specification. And that's where it gets really exciting because you're trading in raw materials, you're adding all the value in one organization, and then we're able to offer that at a price that is very, very competitive. And my job and the rest of the team's job is to get us to that point. And that's why we've got a catalyst project that could underpin, subject to planning, mass production.
So yeah, so how scalable is that vertically integrated factory model you mentioned?
Extremely scalable. So the design I put up on the screen is spec to deliver 2,000 units a year. And we call a unit a 250 square meter GIA house, which could be in some cases considered to be two houses. So you know, we're talking about huge volume potential. Break even is probably about 300 to 400 of those units. We've got all the modeling on that. So yeah, it's really exciting. And all we need is 1 or 2 developers to come on board with us, build out the Catalyst project, and also provide access for us into their other sites, and it's deliverable. So yeah, and we're not going to build a factory and then hope they come. And our strategy is all about, we have to be demand led, outsourced to begin with, primary production of just panel assembly, followed by vertical integration.
Yeah, well, hopefully someone on the call can pick up the system and suggest it to be trialed on more projects around the UK. So we've got another question in the chat about insurability barriers. So beyond fire certification, what insurability barriers have constructors and manufacturers come up against? Is there anyone who would like to take that question?
I would like to, and I'll be quick.
Go for it.
So we were featured a very negative article in the Daily Telegraph last week about us, our flat pack system. That has sparked a lot of interest from other media outlets, Architectural Journal, Dezeen, and others, and an approach from the Ecology Building Society, who have said, look, we want to support you. We want to help announce that we're ready to provide a mortgage for all 2,000 units, which is great. And as with the case study project and the client, we've had a number of meetings with their insurer, the NFU, who are also happy with it. So it's because it's new and innovative, that's the challenge, but we're not seeing any big barriers.
I wouldn't mind just adding to that. If that's
please,
right.
Steve. Yeah.
We see a lot less of it now. It used to be more common as more of the off-site methods and anything other than traditional really was getting pushed. But I've got to say that the BOPAS accreditation is absolutely outstanding for that. I mean, going through BOPAS for us, it really changed some of the management of our business and how we address any sort of eventuality that could come up really, and to be able to keep that health check on that continuously throughout the year, that's a standard that very few other builders do work to outside of this industry. So my personal feeling is that our industry that we're in now and the MMC systems that we're doing are pulling away from the standards that are behind the traditional builds and are really pulling the industry in the right direction. And it doesn't take long and isn't difficult to point that out to an insurer. And when they can see that, then we usually find it's very positive.
Oh, that's really good to hear. And then kind of on a slightly different note, Patrick, I thought your kind of what you're trying to do in Bristol is absolutely brilliant, and I love the kind of like the real application of regenerative design principles. I thought it was absolutely amazing. Kind of talked about insurance, but how have you found those ideas have landed with the local residents in the area? Kind of are people really interested in your new system and way of thinking about housing and kind of the community funding model? How have people reacted to it? Have you got a lot of positive engagement on that?
Yeah, no, it's a good question. So yeah, I think in Bristol, it's the video I showed was very much from We Can Make. So that's their working locally with the local community. So in terms of the competition, the Climate Smart Cities Challenge, we were postulating how to scale up that across the whole of the UK, starting in Bristol. So it was a competition in its own right. So we weren't working with the community for the competition, but actually, you know, in terms of, I'm based in Bristol. Oh, sorry, I'm based in Cambridge, and I'm also a trustee of a new urban room for Cambridge. We've called the Cambridge Room, and I think through Cambridge, yes, we're finding through the opening of the new urban room back in March, there's been a really significant an apparent engagement with the local community in terms of how to build more sustainably. That in particular, not just in terms of new homes, of which Cambridge there will be many, but also in terms of retrofitting residents' existing homes. So it's been, yeah, since March, I think we've been quite taken aback actually in Cambridge. How much interest there has been in terms of what local residents can really do to help not just the environment but also lower their own energy bills and be seen as, or be wanting to be more sustainable. So yeah, in terms of community engagement, there has been this real need, but what there hasn't been is a clarity in how to achieve that need. So I think it's enterprises like We Can Make in Bristol, or like the Cambridge Room here in Cambridge, which can create a bit of a conduit to enable residents to come, to get the agency they need, to be able to work with others to do what they want to do. Because more often than not, and I think that was apparent from this morning's session too, is that we as consultants and contractors come in with clients building homes, and there's just a real lack of meaningful community engagement where we're really engaging and being led by their wishes as well. So in short, yes, to your question.
Yeah, oh, that's great. Yeah, I mean, personally, I mean, as someone who I feel my practical skills are lacking in terms of renovating my own house, so I imagine that's a really, really valued thing for someone to actually explain to you how to do it, how you can do it yourself, and what the best things are to do to make sure you have a kind of you're retrofitting sustainably. So that's brilliant. So kind of zooming out a bit more, and Kat, I was wondering whether I could ask you kind of a question about incentivization for using these low carbon materials and systems. Kind of obviously there are some fantastic solutions out there that we've heard today, but how can homeowners and clients be more incentivized to use these kind of systems kind of across the UK, do you think?
Well, I think, as others have already said, there's a need for robust warranties and right tradespeople, but ultimately education is key. I think raising the awareness of what is available in the market rather than the traditional approach is really important. So homeowners, home builders are actually able to see what is available to them rather than it just be the usual bog standard things that they can get. The other parts, I think, having a holistic system. So we see it with the likes of Octopus Energy offering holistic solutions in terms of what they can do to upgrade their homes from PV, batteries, air source heat pumps, those types of things. But it gives them a guarantee in terms of Octopus. There's no builds guarantee. But I think there needs to be a fundamental change that, it's already been mentioned about cost being the driver for a lot of these things, but actually we need to break that, because where we are using carbon intensive materials, there needs to be a higher carbon tax on that. And actually we need a fundamental shift whereby rather than always be about new build, where we have the opportunity to do refurbishments, we should switch the tax on that. The tax is on refurbished materials rather than new build. And actually that doesn't encourage others to be incentivized to actually reuse what they've already got. So there's quite a few things that need to be shifted, but education is a key part of all of those things. It's not just about the materials that are used, it's a combination of things, actually working practices, and from the supplier, manufacturer, right through to home builders and actually DIY renovators. They've all got a role to play, but so is government.
Yeah, absolutely. And Patrick, can I come back to you on kind of on that role of government and legislation? What kind of changes would you like to see to kind of enable these low carbon solutions to actually come to fruition in more cases around the UK?
Yeah, no, good question. I suppose, yeah, more clarity, more consistency would be helpful. I know the government have probably shot themselves in the foot, haven't they? In terms of aiming for 1.5 million homes by the end of their term, and that's their driver, which unfortunately means that their wishes for that to be more sustainable inevitably takes second row. So yeah, more clarity. I know Part Z was brought up, and I understood that might last year would have been coming this year. I'm not quite sure whether that's going to be delayed again. So having targets to aim for is important, but so long as those targets have the fairness to enable innovation to happen, depending on site specifics. So I know that was brought up as well from Rory, in terms of, you know, that when we're looking at manufactured processes, that we need to understand we need to use the right materials for the right sites, and actually a certain material might be brilliant on a certain scale building, but it's going to run into a lot of problems for larger buildings, or vice versa. So I think in terms of legislation, there needs to be clarity and fairness there, but it's inevitable. It will come, and having those targets will only help for us to achieve our 2050 goal.
Yeah, absolutely. I mean the launch of the recent, well, fairly recent now, launch of the UK Net Zero Carbon Building Standard, I guess, has tried to put some clarity on what net zero should look like for a few kind of typologies within the residential sector, in terms of upfront carbon and energy usage intensity, and a few other metrics too. They are challenging targets, but have they kind of helped you spark any conversations about using more low carbon systems, or kind of thinking of different ways to build buildings with any clients or developers? And that's a question for anyone who has a view on that.
Yeah, it has for us. I mean, specifically, we did have one client approach us to achieve that. Specifically, we've got 24 houses going up on a brownfield site in Devon currently, in conjunction with Octopus Energy. And the key of all of those is that they're going to be zero builds and carbon neutral. So it was a major driver for that project. But not is it only a major driver for that project and that client, but really it's what those houses are being sold on, and hoping to be able to sell them and at a slightly greater revenue point than they would do against what else is being built, which is pretty much all traditional in the area, in quite a large volume as well.
Yeah,
I think we're seeing that the investors are, you know, so large pension funds, for example, you know, have policies, and you know, so they're the ones that we're seeing the push coming from, which is great because they're the ones holding the purse strings. You know, we're seeing, you know, a definite upsurge in interest from, you know, the larger scale projects, which, you know, really is where we need to be getting at, isn't it? We need to be building the sort of large scale projects more sustainably than, you know, while small scale exemplars are always nice and great learning things, you know, at this stage we need to be sort of rolling things out at a bigger scale, don't we?
Yeah.
So the fact that institutional investors are you know, pushing is really good news.
Yeah, that is really good news.
We've found the buildings framework has been very helpful. I mean, not least, I know they publish tables depending on building type, and the reduction of carbon up until 2050. So again, yeah, it's provided, I suppose, a target to benchmark the work that we do against something. And I think it goes back to that consistency, is that at the moment that framework, you know, whether that's then used to be adopted in terms of policy, which we would like to see.
Yeah. No, I totally agree. It's instigated conversations with our collaborators and clients too on what it looks like to meet those targets, which I think is fantastic. But so Kat, coming back to you. So I mean, do you kind of, in terms of Part Z and other government policies and kind of using these targets, like, do you see, I'm very hopeful for Part Z, but do you see it kind of being implemented soon.
I would hope so, but I think we've always got this problem whereby regulation is always behind where the art of the possible is, and I think we've heard today with a lot of the speakers in terms of actually where they're already exceeding existing regulation, they're improving on that. So we always have this imbalance really, and this delay in terms of what's coming down from a policy perspective and regulation, and actually what can be done. And this is where the balance of, you know, what's the drive of things happening? Is it cost, or is it more of a moral? This is what we need to do. This is what the communities want. This is what home buyers want. And marrying that up with investors. So there's always some complexity around that. So things will change, but they're always slow to change. And I think as suppliers and providers in society, we need to respond in terms of doing more rather than waiting for regulation to catch up, because we have that in our gift. I think the other part of it is we are seeing a societal shift as well. So people want zero bill homes. You know, they're looking at it from a long-term perspective. They're not looking at it in terms of the pay costs, but then actually they can't afford to live in their homes or their offices because it's too expensive. They're looking at those things in a very different way from a cost of living perspective, but we're not valuing that in the right way. So when you look at the financial institutions and what they will offer, and then also what we have in terms of estate agents, and you know, are they valuing the benefit of a more sustainable home, one which is not as expensive to run? We see it marginally in the market, but there's a lack of understanding and education in certain areas which are setting those barriers which don't have to be there, because they have a lack of understanding in actually the benefit from a long-term perspective, from a long-term asset residential home, but being more sustainable brings. So therefore, when you look at it from a whole life perspective, the cost is better. When you look at it from a build perspective, yes, sometimes it is more expensive, but we can't look at that in isolation. So if we're waiting for policy and regulation to catch up, we'll be waiting for the wrong thing. We have the opportunity, we have guidance that's already available, so we know what we need to do, and actually we've demonstrated that today. We just need to keep pushing forward and actually working as a collective to make sure that happens sooner. So I know the Future Homes Standard is due hopefully this autumn. It's been delayed, but you know, things will always be delayed. We can't just keep waiting and then say we'll do the minimum.
Yeah, and I guess no, I totally agree, and I think right at the other end of the supply chain as well, we can all be doing things to keep showing that there's demand for manufacturers to create more low carbon materials opportunities. Steve, it sounds like you're doing that as part of your work with your steel suppliers as well. We could talk for a lot longer on all of this. I've loved speaking with you all on this, but I think it's time to close up the session. So Kat, I'll hand back over to you.
Yes, so thank you everybody for your presentations today. I think it's been really informative. I'll do a very quick whistle-stop tour. So Patrick provided an update in terms of combining low carbon materials and adding value to communities, looking at their systemic health and resilience, moving from cost to value and doing more good rather than less bad. But this is really about the way and we build and the what we build to add additional value. So really focusing on thriving neighbourhoods. Then we had Gwilym, who updated us on wall CLT and benefits of prefab. So obviously it allows you to build quicker. It's allowing to standard practice in some areas, but it does require coordination. But it also has better performance when you're looking at it from an air tightness perspective compared to what's in the regulations in Passive House, and they've been able to demonstrate that. Steve provided an update on low embodied carbon steel and obviously demonstrated the challenges in terms of accessing that. We know it has less carbon compared to traditional approaches, with 90% of steel being recovered or recycled, but we need to design to deconstruct and reuse, which is really important in terms of actually from a long-term circularity perspective. You also mentioned about Steel Zero, but also the challenges in understanding actually what is green steel, what does it mean in terms of scrap material, electric arc furnaces, hydrogen instead of iron ore, but also the nuances in terms of the offsetting from an accounting method. But what we really should be focusing on is the emissions per tonne, because that's the important factor overall. And then Matthew updated in terms of Hempsman and the technology organisation and the biohouse system. So which has carbon data which has been verified, but has in its raw form carbon which is carbon negative. But it's taken on passive house principles, and it's really focusing on a climate positive solution, which is supporting employment, new habitats, tourism, education, and new neighbourhoods. We then had from Rory, who's looking at the prefab modular, which again is 50% quicker to build than traditional, which has a focus on buildings, manufacturing. It's brought to site, it's then clad, so it allows for local materials to be used. It also has the flexibility from a modular matrix, which looks at a design to fit whichever site is available. But it's really looking at that from a modular and a more adaptable approach. So those are the main points. So I'd just like to thank all of our speakers. It's been, I think, a very informative session today. So looking back, we have a feedback and CPD poll. So please do fill that in if you would like your CPD for this webinar. So that's running in the background. I would also like to highlight in terms of some of our upcoming events. So we have on the 3rd of September, we have the Antarctic Infrastructure Modernisation Programme webinar. On the 9th, we have the Low Carbon Materials Social Infrastructure. On the 15th to the 19th of September, it's obviously Offsite Construction Week. And then we have the Build Offsite Summit at the Offsites Expo following that. In October, we've got the Low Carbon Materials in Transport and Infrastructure. And in November, we have the Bowpass Forum and the Reedstone Factory Tour in Drillfield. Okay. So what we have here in terms of the different expos, obviously, please do take a look at that in terms of the different challenges that are offered and how to entry. Entries close on the 31st of July 2025. So you can scan that QR code. And then please do take a look at the new approach for collaboration, downtime management, which has got a survey. Please do scan that QR code. But this really is about shaping the future of UK offsite manufacturing and collaborating for change. So the final one is about the RHS Chelsea Flower Show in 2027. So Build Offsite are proud to support this concept. It's a suds garden at the 2027 Chelsea Flower Show, which is collaborating with Refolo, landscape architects, CIRIA, and Future Water. So it's a garden more than an aesthetic. It's about showcasing innovation, resilience, sustainability in a way the public can see, touch, and celebrate. Obviously, we know that it has high coverage with 170,000 visitors, 13 hours of BBC coverage. So it's a really good platform to show the world of what we can do in terms of offsite construction extending into the landscape. So it's not just about factory walls, but in the public eye. Okay, so please do register your interest with the QR code for this RHS Chelsea Flower Show in 2027. Okay, thank you very much. It's been a really good session, and we'll get back to you in terms of the questions that have been raised, and where we can, we'll share the slides as well. Thank you all.
Thank you.